there, my name is Professor Rad, and this is Precalc video 3-4, determining trigonometric values using trig properties. So in this video, we'll be going through the same two examples that we just did in the last video, but this time, instead of using trig definitions to identify these values, we're going to be using our trig identities. Now, these are the trig identities that we need to work to know as well as our name. So I've got them on the board for reference, but we do want to make sure that we're practicing them, working to, know them so that they become a part of us, an essential piece of our soul. Yeah, so let's go ahead and work through this example. So just a reminder, we're going to suppose that cosine of theta is 3/5 and theta lives in the fourth quadrant. And secant of phi is -3 and phi lives between 180 and 270 degrees. And we want to find sine of theta and cotangent of phi. So the first thing that I'm going to do is I'm going to identify the quadrant that these angles live in and use that to help me remember the sign, S-I-G-N, of the answer that we're going to get. So for this one that involves theta, theta is in quadrant 4. So quadrant 4 is over here. And remember, all students take calculus. So the C means that cosine is positive in this quadrant, and the others are going to be negative. So in particular, sine will be negative. So our answer is negative. So that's the first thing I like to do, figure out whether we have a positive or negative value in the end. Next, I want to take the trig value that I know and the trig value that I want to know and see if there is a formula that relates them. So when I look at my trig identities here, none of the reciprocal identities are going to be helpful right now because the one that involves sine doesn't involve cosecant, or doesn't involve cosine, and the one that involves cosine doesn't involve sine. So this is what I have, this is what I need. So I want a relationship that involves both of them. If I look at the quotient property, both of the quotient identities involve both sine and cosine. However, they also involve either tangent or cotangent, which I don't know. All I know is that cosine of theta is 3/5. So although they're both present in the quotient identity, the quotient identities also involve another trig function that I don't have. When I look at the Pythagorean identities, this is where I find a win, because I have cosine and sine and just one. So this trig identity involves the one I know, cosine, the one I don't know, sine, and nothing else. So that's the identity I'm going to use to solve for part A. So we're going to get cosine squared theta plus sine squared theta is equal to 1. And now we just substitute in what we know and solve for what we don't. So cosine of theta is 3/5. So this piece here means I'm going to take that 3/5 and square it, plus sine squared theta is 1. Now to square a fraction, you square the top and the bottom. So we're going to get 9/25 plus sine squared theta is 1. Next, we're going to subtract 9/25 from both sides. Now, when I do this, there's a nifty way to remember subtraction of a proper fraction from 1. So this works in this particular case because we have a proper fraction that we'll be subtracting from 1. Just subtract the bottom minus the top. So if I do 25 minus 9, that will give me 16. That'll be my numerator, and 25 will be the denominator. The reason that this works is because 1 is the same as 25 over 25. So in the numerator, I have 25 minus 9 to get 16, and the denominator stays the same. Lastly, we're going to square root both sides. So we get sine of theta is plus or minus the square root of this, which is 4/5. This is where the beginning part, knowing that my answer was negative, is important because I know I need the negative fraction. So sine of theta is a -4/5. And there we go. That's how we find this first, do this first problem using trig identities. All right, so let's go ahead and do the next one. So the next one, we want to find cotangent of phi. We know that secant of phi is -3, and we know where phi is living. So yeah, so let's draw out where this is first. So we're going to be 180 and 270. So we're over here. So all students take calculus. So this means that the tangent is going to be positive in quadrant 3, which means the cotangent is also positive. That's because the tangent and cotangent are reciprocals, so they have to have the same sign. So I know for this problem that my answer is positive. Now, when I go to find cotangent of phi, I can do the same thing that I did before. I can find an identity that's going to relate both tangent, or sorry, that's going to relate cotangent and secant. So I have a problem. So I have a problem because none of these relate cotangent to secant. That's a bummer. However, remember the key to trig is knowing sine and cosine. So if I know that secant of phi is -3, I can get secant in terms of cosine. And once I have cosine from this previous problem, we know that we can find sine. And once I have cosine and sine, then I can find cotangent. So we're going to end up using all of the properties here, all the identities, in order to help us figure this one out. So first, secant of phi is -3. Secant is the reciprocal of cosine. So that means that cosine has to be the reciprocal of -3. So this is a -1/3. So basically what I did was I took the reciprocal of both sides of this equation. Now that I know cosine, I can use this Pythagorean identity to figure out sine. So I have cos squared phi plus sine squared phi is 1. So I'm going to take a little bit of a shortcut here. So if I square -1/3, I get 1/9. If I subtract that, I'm going to get 8/9. So then sine of phi is going to be plus or minus. The square root of 8 is going to be 2√2. And the square root of 9 is 3. Now, because I'm living in the third quadrant, that's where tangent is positive, sine is going to be negative. So I want the negative 2√2/3. All right. So now we have cosine from secant, and then from cosine, we got sine. So now that we have sine and cosine, we can use the quotient identity to figure out cotangent, which is where we needed to get to. So cotangent of phi is going to be cosine over sine. So we have -1/3 over a -2√2/3. If I multiply the top and the bottom by a -3, I can simplify this complex fraction and just get 1/2√2. And then if I rationalize the denominator, I can multiply top and bottom by the square root of 2. I'm out of space, so I'm going to go over here, and that will give me square root of 2/2, and then √2 is 2. So 2 times 2 is 4. So cotangent of phi is going to be √2/4. And the sign SIGN of this answer was positive, which we needed it to be. Hooray! Okay, so this was a longer way to do this problem. There's actually a shorter way, but as I've mentioned a couple times, you want to remember things in terms of sine and cosine. So as long as you remember those identities, then you can get through this problem using just sine and cosine as your key. If you have more memory space, then you can get away with using the reciprocal and the Pythagorean identity. Is that what I wanted to say? Yeah. So if I know, for example, that cotangent of theta is the reciprocal of tan theta, I can use the Pythagorean identity here. We know secant. So we knew secant was -3. So I can use that to find tangent. And then once I have tangent, I can take the reciprocal to get cotangent. So I don't have to go into sine and cosine. I could take a little bit of a shortcut, but if I don't remember this Pythagorean identity, I can always rely on sine and cosine. They're like our faithful friends, always there for us. So that's going to be it for this video in identifying values using trig properties. In our next video, we're going to be talking about something super important. That's going to be the unit circle. So we'll be talking about some radian and degree measurements and how that all relates to our coordinate plane. So I'm looking forward to working with you there on the unit circle. In the meantime, I hope you found this helpful in working with some identities to determine trig values. And may you have a fantastic day. Bye for now.